Over the past 2 years, artificial intelligence has exploded. AI models have turned computing power into the new focus of innovation.
Marveled at our own magnificence as we gave birth to AI.
AI? You mean artificial intelligence?
But behind every chatbot, image generator, or large language model lies one hidden cost: electricity. If GPUs are the brains of AI, then power is its fuel. And that fuel demand is skyrocketing. Data center electricity use is now soaring so fast that it's starting to strain grids around the world. Section 1. The power black hole of AI. According to the International Energy Agency, global electricity use rose 4.3% in 2024, the sharpest increase in a decade. Data centers were one of the main drivers of that surge. In the United States, the EIA reports that national power demand will hit record highs in 2025 and 2026, driven largely by data center expansion. Wholesale electricity prices in regions like PJM are surging. In the UK, AI startups are already struggling with skyrocketing energy bills. Training a single large AI model, something like ChatGPT, can consume millions of kilowatt-hours of electricity. That's equal to hundreds of years of household power use. In fact, the annual data center consumption of companies like Microsoft or Google already exceeds that of some small countries. The AI boom is not just about algorithms, it's accelerating the need for massive power infrastructure upgrades. Section 2. Why data centers consume so much power. Data centers are, in effect, small industrial towns. Their energy density is enormous. They run non-stop, 24 hours a day, 7 days a week. Even a few seconds of downtime can interrupt AI training and cost millions in losses. And beyond performance, there's another challenge: sustainability. Tech companies face mounting ESG and net zero targets, forcing them to use more renewable energy. So data centers need power that is large-scale, reliable, and low-carbon. But traditional grids can't always deliver that. They expand too slowly, face volatile electricity prices, and struggle with extreme weather. Section 3. PPA, Tech Giants' Green Insurance. To deal with these challenges, major tech firms are turning to power purchase agreements, or PPAs. Through PPAs, companies sign long-term contracts, often 10 to 20 years, with renewable developers to secure stable supplies of green electricity. It's like buying an energy insurance policy against future volatility. But while PPAs solve the long-term supply issue, they can't solve a bigger problem: intermittency. Wind and solar don't produce power 24 hours a day. That's why energy storage has become essential for data centers. Section 4. Energy storage, the standard for data centers. Energy storage is no longer optional. It's becoming the new safety net for the AI era. Storage allows data centers to charge when electricity is cheap and discharge when prices spike, a strategy known as peak shaving. It also provides seamless switching, kicking in within milliseconds if the grid fails. That means uninterrupted compute, even during outages. And when coupled with solar or wind, it enables partial green self-sufficiency, helping companies reduce their carbon footprint. Across the world, energy storage is rapidly becoming a standard component of next-generation data centers. Section 5. Challenges, the hurdles of the AI energy revolution. Still, the AI energy revolution faces some big hurdles. First, grid expansion lags behind. Building new transmission infrastructure takes 5 to 10 years, but data centers can be constructed in just months. Second, renewable energy is intermittent, while AI requires power that's constant and instantaneous. Short-duration storage often can't bridge the long gaps between renewable generation and round-the-clock demand. Third, storage remains expensive, and regulation hasn't caught up. Long-duration systems like flow batteries are still in early commercial stages. Microgrids can offer off-grid supply, but policy frameworks remain inconsistent. In California, for instance, multi-property microgrids face restrictions. Meanwhile, West Virginia allows private microgrids to bypass oversight, but faces local land and tax disputes. These mismatched policies show how the regulatory system is still catching up with technological reality. Section 6. A bright future, AI and energy in synergy. Despite the challenges, the outlook is bright. As storage costs fall and renewable technologies mature, data centers are gaining access to cleaner, more stable power. At the same time, AI itself is beginning to improve the energy system. Machine learning models are optimizing energy dispatch, predicting demand, and fine-tuning storage efficiency. A diverse mix of solar, wind, lithium-ion, flow batteries, and second-life microgrids is emerging to power the digital age. In the end, AI doesn't just consume electricity, it's helping to reshape how we generate, store, and manage it. The future will be a virtuous cycle. AI optimizes energy. Energy sustains AI. Together, they'll form a cleaner, more efficient, and more sustainable global energy ecosystem. Conclusion. The rise of AI has made data centers the new front line of the global power system, and energy storage is becoming their backbone. This is not just about keeping servers running. It's about building the infrastructure for an intelligent, electrified world, one where computing and clean power evolve hand in hand. AI runs on power, and energy storage is what keeps it alive.